Have you ever found yourself, maybe mid-afternoon, just wrestling with your inbox?
Yeah.
Buried under a mountain of emails that all seem urgent?
Oh, yeah. Or clicking through endless calendar invites just trying to find one time slot for a simple meeting.
Exactly.
Yeah.
That familiar administrative friction, that sort of daily grind of routine tasks, it's actually the perfect way to think about this next major leap in artificial intelligence.
hmm
For a while now, we've all gotten pretty used to AI copilots, haven't we? Those helpful assistants that maybe draft an email for us or summarize a long document, suggest a line of code.
And they're great, super helpful for productivity.
Hmm.
They augment our work, give us smart suggestions.
And this is the key thing. At the end of the day, we still have to be the ones to make the final click, right?
Right.
To actually hit send or confirm the booking, accept the code suggestion. They assist.
That's where assist.
But something really profound is shifting. I mean, right now, beneath the surface, we're moving into an era where AI isn't just suggesting things, it's actually deciding and acting on its own.
Right. Think about an AI agent that literally sends those emails for you, books those meetings without you double-checking every option, maybe even moves money between accounts or files IT tickets. Yeah. All without you lifting a finger for each specific step.
It's not just a small productivity hack anymore, is it? It feels like a fundamental, almost transformative change in how work gets done. And the implications, well, they're potentially massive for every single one of us.
And that precisely is what we want to dig into in this deep dive. We're here to explore this incredible, honestly transformative shift from AI assistants to co-pilots to these powerful decider AI agents.
So what are we covering?
Well, we'll delve into the very core of how these autonomous AIs actually function, what makes them tick. Then the critical safety measures, the guardrails, as they're often called, that are absolutely required for deploying them responsibly.
That sounds crucial.
It really is.
Yeah.
And perhaps most importantly, how do you effectively measure their impact? How do you prove their value in the real world? We'll also touch on the brand new team structures and operational models, the agent ops that are starting to emerge around them.
And where are we getting this info from?
We're drawing insights from all over, cutting-edge industry reports, the latest company product descriptions, even some rigorous academic research to give you a really comprehensive understanding.
Okay, great. So our goal today is really to equip you, our curious listener, with the knowledge to not just understand these powerful new AI teammates, but hopefully to feel comfortable enough to responsibly deploy and effectively manage them in your own work life.
And uncover some surprising facts, maybe some crucial insights along the way. Help you navigate this rapidly evolving landscape with a bit more confidence.
Okay, so let's start with what most of us already know, because it's a good baseline, right? Many of us are pretty familiar with AI assistants or co-pilots at this point.
Definitely. They've sort of seamlessly integrated into our digital lives, often so subtly we barely notice them anymore.
Yeah, like a GitHub Copilot. Lots of developers use that now.
That's a perfect example. It's positioned as an AI pair programmer, right? Its main job is to help you build with you by generating code suggestions.
Right, it suggests snippets, maybe whole functions.
Exactly. It's trained on vast amounts of natural language and public code, and it's incredibly effective at speeding up development by drafting code.
Mm-hmm.
But you, the human developer, you review what it suggested. You accept it, or you tweak it, or ignore it. The ultimate decision, the action, it stays with you.
Or, take Notion AI. Millions of people use that for writing help.
Another great one, assisting with creating and editing documents, translating text, maybe generating flowcharts, or even autofilling databases with summaries.
It summarizes, it drafts, it gives you a first pass, which is immensely helpful, don't get me wrong.
Absolutely. But again, it's still operating squarely within that realm of suggestions and content generation. It requires human review and, crucially, human action to finalize anything.
The same applies to Slack AI, right? Summarizing channels, recapping conversations, translating messages.
These tools undeniably enhance productivity, no question. But their core function remains drafting or suggesting. They aren't initiating communication on their own. They're not making commitments for you.
Okay, so that's the familiar ground. Now, where does this profound shift happen? You said from drafting to doing.
Exactly. That's the heart of it. An AI agent is fundamentally different. It's a software program designed not just to process information, but to actively interact with its environment, collect data, and here's the key phrase, independently perform self-directed tasks to achieve predetermined goals.
Independently perform self-directed tasks. Okay, so humans set the goal, but the AI figures out how to get there.
Precisely. While humans still set the overarching objectives, we define what success looks like. The why, the agent itself, determines the best, most efficient actions to take to reach those goals. The how. It's a significant, almost philosophical leap in autonomy.
That is a huge distinction. So when we talk about what makes an AI an agent rather than just an assistant, there must be some core principles, right? Some defining characteristics that set them apart.
Absolutely. And understanding these is key to grasping their potential. According to AWS, who thought a lot about this, there are several key principles that really define these AI agents.
Okay, like what?
First, they are objective-driven. This isn't just about following a preset script like simple automation. It means the AI is constantly evaluating its actions against performance metrics, self-correcting, optimizing.
So it learns and adapts its approach.
Yes, often discovering more efficient pathways we, as humans, might not have even conceived. Think about an AI logistics system. It isn't just finding a route. It's dynamically optimizing delivery routes across an entire fleet in real time, simultaneously balancing speed, cost, and fuel consumption to meet a complex objective.
Wow, that level of dynamic optimization is something else.
It really is. Second is perception. AI agents interact with their environment by continuously collecting data. This could be through physical sensors, sure, but more often it's digital inputs, or, crucially, through APIs connecting them to external systems.
So they see the digital world around them.
In a sense, yes. This constant data stream allows them to understand their context, recognize changes, and update their internal understanding of the situation. Third, they exhibit proactivity.
Meaning they don't just wait to be asked.
Exactly. Instead of just reacting to inputs after they happen, agents can take initiative based on forecasts and predictive models. Imagine an AI customer service agent that sees patterns suggesting a user is getting frustrated and proactively reaches out to help before a support ticket is even filed. It anticipates the problem and acts to prevent escalation.
That's a game changer right there, moving from reactive responses to proactive engagement. It's almost like they're anticipating our needs before we even voice them.
Precisely. It's about seeing around corners, not just answering questions. The fourth principle is continuous learning. These agents aren't static. They improve over time.
How does that work?
By learning from past interactions. They identify patterns, incorporate feedback, maybe from the environment, maybe from human oversight, and constantly refine their behavior and decision-making. Think of predictive maintenance agents learning from past equipment. Failures to get better at forecasting future issues. They get smarter about preventing breakdowns.
So they're not just executing, they're evolving.
Fifth, they're designed for adaptability. Agents adjust their strategies when circumstances change. They can handle uncertainty or novel situations they haven't encountered before. A stock trading bot, for instance, might have to adapt its strategy during a sudden market crash.
Makes sense. They need to cope with the unexpected.
And finally, collaboration. This is crucial for how they fit into our world. Multiple AI agents can work together, exchanging data, coordinating actions.
Like a team of bots.
Exactly. Or they can even cooperate with human team members to achieve shared goals. We see this with autonomous vehicles collaborating to avoid congestion, or in business where different AI agents in, say, sales and logistics might coordinate to fulfill a complex customer order seamlessly.
So bringing it all together, this means AI is now capable of directly, sending emails, booking meetings, moving money, and filing tickets without you clicking a thing.
That's the bottom line. It's action, not just suggestion. Real-world execution.
What's fascinating here is that this isn't just theory anymore. We're not just talking about research papers or future concepts. There are actual platforms, tools out there right now dedicated to enabling this new paradigm of AI action. Tools you and I could potentially start using.
We're definitely seeing a proliferation of robust tools designed specifically to deploy these decider AIs. Take Amazon Q Business, for example.
Okay, what does that do?
It's a generative AI-powered assistant that doesn't just find information, but critically, it also takes action. It lets users create and share task automation applications for routine stuff, like submitting time-off requests or, as we mentioned, sending meeting invites.
And it works within existing tools.
Yeah, securely within popular web browsers and apps like Slack and Microsoft Outlook using extensions. Then there's Amazon Q Developer.
Focused on coding, I assume?
Right. It offers what they call an agentic coding experience. It automates complex, multi-step tasks like generating unit tests, writing documentation, doing code reviews.
How? By just suggesting the code.
No, by intelligently performing actions like actually reading and writing files, generating code diffs, running shell commands. It's interacting directly with the development environment. It's even scored highly on benchmarks like the SAP Bench leaderboard, showing it can perform these tasks really well.
So it's not just drafting code for a developer to copy-paste. It's actively engaging with the code base, identifying issues, implementing fixes, running tests. That is a huge leap.
Exactly. IBM is another major player here with Watsonix Orchestrate.
What's their focus?
It's designed to help enterprises create, deploy, and manage AI assistants and agents, specifically for automating business and customer-facing processes. IBM is quite explicit about this shift. They suggest businesses should move from systems of intelligence, where AI mainly provides insights, to systems of action.
Systems of action. I like that term.
It captures the essence, doesn't it? And then you have platforms like Zapier, which many people know for basic automation.
Right, connecting different apps.
Well, now it acts as an AI orchestration platform. It allows users to embed AI as a step in a workflow, or as an autonomous agent, or even a customer chatbot. And it connects top AI models to over 8,000 different SaaS applications.
Wow, 8,000. So an agent could draft an email in Outlook via ChatGPT.
And then send it. Or automatically respond to Google My Business reviews using Gemini. Not just formulating the response, but posting it.
Got it. Who else is in this space?
Atlassian has jumped in with Rovo. It provides AI teammates, their term integrated with search, chat, a studio, and agents, all driven by a team's collective knowledge within their existing ecosystem, like Jira, Confluence, and Jira Service Management.
So the AI acts with the context of your company's specific stuff.
Exactly. And beyond these big commercial offerings, there's a really vibrant ecosystem of open source frameworks for people building custom solutions.
Like what?
Tools like AutoGen offer a powerful framework for building multi-agent systems. Think sophisticated conversational AI, where different specialized agents can talk to each other to solve complex problems.
Agents talking to agents.
Interesting.
Yeah. AutoGPT provides a platform for building, deploying, and managing agents for all sorts of use cases, like transcribing a YouTube video, having an agent identify the most impactful quotes, and then another agent automatically posting those quotes to social media.
Fully automated content creation pipeline. Pretty much. LangGraph is another important one. It's a low-level orchestration framework. Companies like LinkedIn and Uber apparently trust it for building long-running, stateful agents.
Stateful, meaning they remember things.
Exactly. They can remember conversations and tasks over extended periods, which is crucial for complex workflows that aren't just one-shot actions.
And Microsoft has semantic kernel, right? You mentioned an agent-to-agent protocol there, A2A. What does that enable?
Yes. The A2A protocol in semantic kernel is really crucial. It basically allows different AI agents, maybe built by different teams, using different tools, maybe even from different companies, to communicate and collaborate seamlessly.
Like a common language for bots.
Kind of, yeah. It enables a more sophisticated, interconnected digital workforce. Imagine an agent in HR needing to coordinate with an agent in finance. A2A allows them to pass tasks and information back and forth directly. It breaks down silos between different AI systems.
That sounds key for building really integrated AI ecosystems.
It absolutely is. And it's
Yeah.
worth noting, many of these cutting-edge tools, both commercial and open source, are often powered by what IBM highlights as a strategic shift towards small, fast, open models.
Yeah.
These tend to be more efficient, more adaptable, and sometimes easier to customize than the giant monolithic models.
Okay, so if these AI agents are truly doing things for us, sending emails, booking meetings, maybe even managing code, the immediate question that leaps to my mind is, how much control do we actually keep? Because it's clearly not an all-or-nothing switch, is it? We can't just, unleash them on our critical systems without understanding the different levels of independence. How much leash do we give them?
You've hit on a critical point. It's probably the central question for responsible AI deployment right now. The industry is starting to talk about this progression of AI independence using the concept of an autonomy ladder.
An autonomy ladder. Okay, tell me more.
It basically represents increasing levels of AI self-direction. At the very bottom, level 0 or L0, we have suggest.
Ah, like our familiar co-pilots.
Exactly. This is where traditional AI assistants and co-pilots reside. They offer ideas, drafts, suggestions, but a human is always firmly in control, deciding whether or not to act on the AI's output. Think of a grammar checker suggesting a correction. You click to accept it. Helpful nudge, nothing more.
Okay, L0's is suggest. What's next?
Moving up the ladder, at level 1 or L1, we have approve. At this stage, the AI agent actively proposes an action, but, and this is key, a human must explicitly approve it before execution.
So the AI does the work of figuring out what to do, but waits for a green light.
Precisely. A great technical example is Azure OpenAI's function calling feature. The model responds with a structured proposal, a JSON object detailing a function it wants to call. The developer or the user then explicitly executes that call based on the proposal. You maintain direct, explicit control.
So it's like a highly efficient intern who prepares a detailed plan, does all the legwork, but brings it to you for the final sign-off before proceeding.
That's a perfect analogy.
Okay.
Then we climb higher to level 2, or L2, AutoAct with the spot check.
AutoAct. Okay, now we're talking autonomy.
Yes. Here, the AI agent performs actions autonomously. It executes tasks without requiring human approval for every single step. However, and this is the crucial part, these actions are followed by regular or periodic human reviews of its activities or outcomes.
So it does things, but we check up on it afterward.
Exactly. This level relies heavily on really robust audit logs. Tools like Baby AGI implement comprehensive tracking of function executions, what it did, the inputs, the outputs, any errors. This allows for post-action verification and continuous learning. You ensure it stays on track. It's like having a trusted team member who handles things independently,
Yeah.
but you still review their work periodically.
Makes sense. And the top level.
Finally, at the highest rung, we have level 3, or L3, full autonomy with rollback.
Full autonomy. Wow.
In this scenario, the AI agent operates almost entirely independently, making decisions, executing actions without constant human approval or even necessarily regular spot checks for every single action. However, and this is absolutely crucial, robust mechanisms must be in place to undo or revert actions if they go awry.
Ah, the rollback, the undo button.
Exactly. This rollback capability is the ultimate safety net at this level. It allows humans to intervene and correct course if the autonomous actions lead to unintended or problematic results. It's the AI acting as a fully empowered team member, but with a critical safety feature built in.
It really sounds like, regardless of which level of autonomy you're operating at, maintaining some form of human in the loop is absolutely vital. It just looks different at each level.
You're absolutely right. The human in the loop isn't just a concept. It's a fundamental operational pattern for responsible AI. How it's implemented just changes.
So what are the common patterns?
Well, for level 1, it's all about approvals. Clear workflows where the AI's proposed action is presented to a human for a definitive yes or no before anything happens.
Okay.
For level 2, it transitions to spot checks. This means regular sampling and review of the agent's actions, its outputs, the logs it generates. You need processes to ensure performance stays within bounds and to identify any deviations or anomalies. Maybe you review 10% of transactions or flag certain types of actions for review.
Got it. And for L3?
For level 3, the crucial pattern is rollbacks. The immediate ability to revert or undo problematic actions is the fundamental safeguard when the AI is acting fully autonomously. This requires careful system design from the outset to ensure actions are reversible and that data integrity can be maintained even if you have to undo something.
This balance between human intention and AI autonomy. It's really fascinating, especially when we look at areas we might not typically think of as agents making business decisions, not just booking meetings, but something fluid, adaptive, maybe in creative fields.
That's an excellent point because AI agents aren't just about transactional automation like sending emails or filing tickets. Consider a tool called Elastica that came up in our research.
Elastica, what does it do?
It's an augmented reality storyboarding tool. Now, it's not a business decider in the sense of moving money, but it demonstrates a really interesting form of adaptive AI. It dynamically adjusts predefined graphic animations based on a presenter's real-time speech and gestures.
So the visuals respond live to the speaker.
Exactly. It offers predefined presentations with elastic mappings, as the researchers call it. It tries to blend planned visual quality with live spontaneity.
And how well did it work? What did they learn?
The insights from Elastica's evaluation really highlight these nuances of human-AI collaboration. The user studies showed it successfully managed about 73–74% of performance deviations, things like speech errors or inaccurate gestures the presenter made. And this significantly increased the presenter's confidence. That's a huge win for live presentations.
Okay, sounds good so far.
But there was a flip side. Participants sometimes felt a lack of control over the exact animation path generated in real time, even though the AI was adapting to them.
Ah, the control issue again.
Right. And there were also instances of flawed adaptations. Things like animations starting too early because a static hand gesture was misinterpreted, or graphics moving to weird positions because of poor lighting, or the presenter forgetting a specific gesture.
So it wasn't perfect.
No, and it underscores a crucial insight. Even with highly adaptive, seemingly autonomous AI like this, human oversight, continuous iteration, and a deep understanding of the AI's limitations are absolutely critical. You need to know how it adapts and where it might stumble. It truly is a collaborative interplay, as the paper puts it, between human performance and intelligent adaptation. The AI can elevate the human, but the human still needs to guide, refine, and understand the AI partner.
Okay, here's where it gets really interesting for me, and maybe a little scary. If these AIs are deciders, actively taking action, making choices independently, what robust mechanisms do we absolutely need to put in place? How do we ensure they operate safely within acceptable boundaries? This isn't just about efficiency anymore, is it? It's about maintaining trust, ensuring accountability, and preventing potentially catastrophic errors, especially if they're handling sensitive operations or finances.
You've hit on the core challenge and, frankly, the core responsibility facing any organization looking to deploy these agents.
Right.
Robust guardrails aren't just a nice-to-have, they are absolutely non-negotiable.
Non-negotiable.
Okay, these are the critical controls that prevent unintended consequences, maintain trust, and ultimately ensure that the AI serves us, not the other way around. They're the essential protective framework.
So what are the key guardrails we need to think about?
First among these are scopes. This means clearly, rigorously defining the precise boundaries of an AI agent's permissible actions. What can it do, and just as importantly, what can't it do?
Limiting its playground, basically.
Exactly. An AI agent designed to manage HR onboarding requests should never, ever have the ability to access or interact with, say, core financial systems or sensitive customer databases. It has no business touching. These scopes need to be tightly defined and technically enforced.
Okay, scope is number one. What else?
Second, spend limits. This is a very practical, real-world concern. We need to cap the financial expenditure an agent can incur. This could be costs for API calls, cloud compute resources, maybe even third-party services it uses.
Right, because AI can get expensive if it runs wild.
For sure. Azure OpenAI models, for instance, incur costs based on token processing and image generation. Amazon Q Business has pricing tiers based on users and index capacity. Setting clear, hard limits prevents those horror stories of unexpected massive cloud bills, keeps the AI cost-effective.
That's not just theoretical. That's a real risk keeping CFOs awake at night. No one wants an AI accidentally running up a six-figure bill because it got stuck in some kind of loop.
Precisely. Third, sandboxing. This is about running AI agents in isolated, secure environments.
Like a digital quarantine zone.
Sort of, yeah. It's a critical security measure. It prevents a malfunctioning or potentially compromised agent from impacting the broader system, accessing sensitive data outside its defined scope, or causing damage to core infrastructure if something goes wrong.
Are there specific warnings about this?
Yes. Research projects like OpenHands specifically warn against multi-tenant deployments, where multiple users' agents might run in the same environment without strong built-in authentication and isolation. Other frameworks like Small Agents emphasize using sandboxed execution environments via technologies like Docker or E2B for security.
Got it. Sandboxing is key. What's next?
Fourth, audit logs. This is fundamental. You need to maintain comprehensive, immutable, meaning unchangeable and easily accessible records of every single action taken by an AI agent.
Why immutable?
So you have a trustworthy record. It's crucial for transparency, for accountability if something goes wrong, and absolutely essential for debugging and understanding agent behavior. Tools like Baby AGI, again, implement very comprehensive logging systems that track function calls, inputs, outputs, execution times, errors, even dependency relationships between tasks. This gives you an invaluable, unalterable trail for review, troubleshooting, and compliance audits.
Okay, scope, spend limit, sandboxing, audit logs. Is there one more? The ultimate safety net.
Yes. The one that provides definitive human control in an emergency. The kill switch.
The big red button.
Essentially, yes. It needs to be an immediate, easily accessible mechanism to disable or halt an AI agent instantly if it malfunctions, behaves unexpectedly, or poses any kind of risk. It's the critical last resort for human control, ensuring that we always have the ability to pull the plug or cut the wire if things go sideways. It gives humans the final override no matter what.
That feels reassuring. Beyond these technical controls, though, what about the broader regulatory and compliance landscape? How are governments and organizations thinking about responsible AI deployment when these agents have this level of autonomy?
That's a huge piece of the puzzle. The deployment of AI agents isn't just a tech problem, it's deeply intertwined with ethics and legal compliance. The most prominent example is the EU AI Act.
Right, we hear a lot about that.
It's not just another regulation, it's the world's first comprehensive legal framework specifically for AI. Its stated aim is to foster trustworthy AI and position Europe as a global leader in AI governance.
How does it work?
It uses a risk-based approach. It classifies certain AI use cases as high risk, think critical infrastructure, education, employment decisions, biometric identification, law enforcement, migration control, justice administration.
So, areas with major societal impact.
Exactly. And for these high-risk systems, very strict obligations apply before they can even be put on the market or into service. These include things like adequate risk assessment and mitigation systems, using high-quality data sets to minimize bias and discriminatory outcomes, providing detailed documentation for authorities, and critically mandatory human oversight measures.
Human oversight is baked into the law for high-risk AI.
Yes. The Act also has specific rules for general-purpose AI models, or GPAI, the big foundational models, especially those that might carry systemic risks. The focus there is on transparency, documentation, and respecting copyright. Some of those GPAI rules start applying in August 2025, and the full Act becomes applicable by August 2026. Some parts, like prohibitions on certain AI practices and requirements for AI literacy, actually started applying back in February 2025.
AI literacy obligations, so companies need to train their people.
Yes, the Act recognizes that people interacting with AI systems need to understand them. Beyond the EU, you have things like the NIST AI Risk Management Framework in the US. It was released in January 2023, and it's a voluntary, consensus-driven framework aimed at improving AI trustworthiness while still promoting innovation.
So more guidance than hard law there.
Correct. And data protection authorities like the ICO, Information Commissioner's Office in the UK, are constantly reviewing and updating their guidance on AI and data protection, especially looking at things like AI in employment practices and worker monitoring, often influenced by new national laws. These frameworks are all trying to keep pace with the technology.
So it sounds like companies themselves are also stepping up, maybe going beyond what regulations strictly mandate because their reputation and customer trust are so critical here.
Precisely. Leading companies are proactively adopting stringent security and privacy measures. Airtable, for instance, explicitly states its commitment to protecting customer data through continuous security tech advancements, regular employee training, and aligning with industry regulations. They offer certifications like SOC 2 Type 2, ISO 27001, IPA compliance, plus features like customizable permissions, access restrictions, and even enterprise key management for data residency control.
Giving customers control over their data.
Yes. Notion AI takes a similar stance, contractually prohibiting their AI subprocessors from using customer data for model training. They emphasize secure encryption, hold SOC 2 and ISO 27001 certs, and have a zero data retention policy for their LLM providers. For most plans, meaning your private data isn't used to train their general models.
That no training on customer data seems like a key promise.
It's becoming table stakes for enterprise AI. Anthropic also clearly states they don't train models on user-submitted data without explicit permission and haven't used any to date. Atlassian, with their Rovo agents, emphasizes strong privacy principles focused on transparency, trust, and accountability.
Okay, so alongside these broader compliance frameworks and company policies, are there specific risks tied to agents that we need to actively mitigate?
Definitely. We mentioned prompt injection earlier. It's a significant security concern where malicious inputs, carefully crafted text prompts can trick or manipulate an AI agent's behavior.
Make it do things it shouldn't.
Exactly. Cause it to deviate from its intended function, leak sensitive information, or even take unauthorized actions.
No.
IBM highlights this as a serious evolving threat, and prompt engineering attackers are constantly finding new ways to jailbreak or hijack AI through the prompt itself.
Wow. And what else?
Another big one is hallucinated actions. This is where the AI doesn't just say something incorrect, a hallucination, but it actually takes an action based on that incorrect or fabricated information.
Like that infamous example of Google's AI overview suggesting putting glue on pizza. Imagine if an agent acted on something like that in a business context.
Exactly. It could lead to incorrect orders, wrong financial entries, maybe even dangerous operational mistakes. Mitigating this requires safeguards like human reviews. especially at L2 autonomy. Prompt engineering techniques also help instructing the model clearly, like only use the functions you have been provided with or ask for clarification if a user request is ambiguous, as Azure OpenAI suggests. These explicit instructions help keep the AI grounded.
Makes sense. Constraining its behavior through instructions.
And finally, managing data access and usage remains paramount. The principle of least privilege is absolutely crucial here. Only give the agent the minimum necessary access required for its specific job. Don't give it the keys to the kingdom if it only needs access to one room. User confirmation steps are also highly recommended for any actions with significant real-world impact, like executing code, deleting data, or updating critical databases. IBM's recent Cost of a Data Breach report really stresses the need to navigate this AI rush without sidelining security. Speed is tempting, but safety has to come first.
Okay, so we've talked a lot about what agents are, the different levels of control, the guardrails, the risks. But let's get practical. What does this all mean for us day to day? Where are these AI agents moving beyond theory and actually making a tangible, demonstrable difference in the workplace right now? Where are they truly taking action on our behalf? It's exciting to hear about the capabilities, but how are they actually, upgrading or even taking over real job functions, not just assisting?
That's a great question because they are being deployed across a really remarkable range of business functions already. They're tackling complex, multi-step tasks that used to eat up a ton of human time. They're not just hypothetical, they're in production in many places.
Okay, like where? Give me some examples.
Let's start with something relatable. Inbox triage and scheduling. AI agents can now automate routine email management with a level of autonomy that goes way beyond simple filters or canned responses.
Oh, so?
Well, platforms like Zapier offer templates that can, for instance, not only draft email copy for Microsoft Outlook with ChatGPT, but then actually send that email based on triggers or automatically respond to Google My Business reviews with Gemini.
So it closes the loop, drafts and sends.
Exactly. And Amazon Q Business can streamline tasks and accelerate problem solving, including direct actions like analyzing your calendar and colleagues' calendars to send meeting invites that work for everyone, or submitting time-off requests directly into the HR system. It handles the back-and-forth negotiation for scheduling.
That alone sounds like a massive time saver, just the meeting scheduling hassle.
It really is. It frees up hours spent on those repetitive administrative tasks, letting humans focus on the content of the meeting, not the logistics of setting it up.
Okay, inbox and calendar makes sense. What else?
How about notes to tasks and document analysis? Notion AI, for instance, offers AI meeting notes that don't just transcribe. They can summarize, automatically identify action items, and then autofill databases with summaries and insights, connecting what was discussed to actual tasks or project tracking.
Turning conversation into action items automatically.
Right. Airtable Assistant is another example. It helps businesses extract line items, costs, and specs from PDFs, making unstructured data like invoices or spec sheets and turning it into structured, usable data in a database.
And it's huge for data entry.
Definitely. It can also turn customer calls into product intelligence by analyzing transcripts, categorizing recurring themes or issues, and updating dashboards in real time. So you get immediate insights from customer interactions. And research systems like MemGPT are exploring how agents can analyze large documents that far exceed the underlying LLM's context window.
What does that mean, exceeding the context window?
So an LLM's context window is like its short-term memory, the amount of text it can hold in mind at once. It's usually limited. Tools like MemGPT use clever techniques to allow agents to effectively process and reason over documents that are much, much larger than that limit. Think analyzing entire books, massive legal contracts, or huge research archives. It unlocks deep analysis of vast amounts of text.
Wow. Okay, what about customer support or internal operations?
Support and operations is a huge area for agents. The AWS definition we discussed earlier used the example of a contact center AI agent that automatically asks the customer different questions, looks up information in internal documents, and responds with a solution, only escalating to a human when it gets stuck.
So handling the whole interaction for common issues.
Yes, the initial diagnosis, information retrieval, and even resolution. Amazon Q Business is specifically designed for internal help desks, IT, HR, and benefits help desks. It provides immediate permission-aware responses based on enterprise data, drastically cutting wait times for employees.
Permission-aware is key there, right? It only shares what it's supposed to.
Crucial. IBM watsonx Orchestrate also aims to automate and simplify business and customer-facing processes by creating agents that can, say, process customer complaints, initiate refunds according to policy, or update account details. And Atlassian's Rovo provides those AI teammates directly within Jira, Confluence, and Jira Service Management, so they can act within existing project management and support workflows like updating ticket statuses or finding related documentation.
So these agents are acting as sophisticated first-line responders, triaging, resolving common stuff, freeing up human agents for the really complex, nuanced, or maybe more empathetic interactions.
That's exactly the model.
What about areas involving sensitive data or, actual money like finance and sales?
Well, our sources didn't detail specific AI agents making autonomous financial transactions beyond that general phrase, moving money, but the underlying capabilities certainly point towards future applications.
Like what?
IBM watsonx Orchestrate is built to accelerate the impact of generative AI in core workflows, which strongly implies potential in finance for tasks like advanced fraud detection, automated compliance monitoring, or perhaps streamlining parts of financial reporting and analysis.
And sales.
For sales, tools like Slack AI can help teams get essential customer context and sell smarter by summarizing account channels. An agent could extract key insights from call transcripts or email threads and automatically update the CRM record, maybe even suggest next steps. IBM explicitly highlights AI in sales as a major transformation area, with agents potentially automating things like lead qualification, drafting personalized outreach emails, or managing follow-up sequences.
Automating the sales pipeline to some extent?
Exactly. But perhaps the area where agents are having the most immediate and profound impact right now is software development.
We touched on Amazon Q Developer.
Right, providing that agentic coding experience, automating complex tasks like writing unit tests, documenting code, performing code reviews, not just suggesting, but executing these actions, reading files, writing files, generating diffs, running shell commands, verifying output.
It's actively participating in the development cycle.
Deeply. IBM watsonx Code Assistant has similar goals. Accelerate developers' productivity and reduce time to market by infusing AI into the entire application lifecycle,
Oh,
from initial coding right through to deployment and testing. And those open source frameworks we mentioned, AutoGen, AutoGPT, LangGraph, Semantic Kernel, they're specifically built to empower developers to create, deploy, and manage these kinds of autonomous coding agents. We're seeing agents capable of building entire software components with minimal human intervention.
that really does sound like a massive upgrade for software teams, potentially allowing them to iterate much faster, focus more on high-level architecture, complex problem solving.
That's the vision, letting the agents handle more of the routine implementation and verification.
What about the more creative fields? Design, maybe?
Mhm.
Are agents making a difference there too, beyond just, generating an image from a text prompt?
Absolutely. In creative and design industries, while it might not always be deciding in the same transactional sense, AI is taking significant actions. Take Figma AI, for example.
Figma, the design tool.
Yeah. They've introduced features like visual and asset search, which uses AI to understand the semantic meaning of images and components, not just keywords. Makes finding the right design element in a huge library much easier.
More intuitive search.
Right. And they have productivity updates, where AI can translate, shorten, or rewrite text directly on the canvas, generate realistic copy and images to fill mockups, remove image backgrounds automatically, and even automatically rename layers to keep complex design files organized, something designers spend a lot of time on.
Automating tedious design tasks.
Exactly. And their Make Designs feature is really interesting. It can generate UI layouts and component options from your text prompts, effectively tackling the blank canvas problem by giving designers intelligent starting points and variations to work from.
So generating initial design structures.
Yeah. And remember Elastica, the adaptive presentation system. That's another example in a creative context, AI taking complex actions to adapt visuals in real time to human performance, enhancing expressiveness. So yes, agents are moving beyond mere suggestions to taking direct, often multi-step actions across a really diverse range of industries, fundamentally reshaping how work gets done.
Okay, this shift towards autonomous agents, it really forces us to confront the risks head on, doesn't it? As these AIs gain more power to act on their own, what new or maybe magnified risks are we introducing into our systems and workflows?
It's a critical question.
And just as importantly, how are regulators, standards, bodies, and organizations themselves responding? How are they trying to ensure safety and trustworthiness in this rapidly evolving landscape? We talked about guardrails like the kill switch, but what are the specific threats that keep security folks up at night?
Well, the increased autonomy definitely brings a new set of critical risks that demand proactive management and really robust compliance frameworks. One of the most significant security concerns, which we touched on briefly, is prompt injection.
Right, tricking the AI with the input.
It's exactly. Malicious inputs, cleverly crafted prompts, can be designed by an attacker to manipulate an AI agent's behavior, to make it bypass its instructions, deviate from its intended function, leak confidential data, or even take unauthorized, potentially harmful actions. IBM's research on prompt engineering explicitly flags prompt injection attacks as a serious, evolving threat that organizations need active defenses against. It can be surprisingly effective at bypassing traditional security.
So it's a direct attack vector through the agent's primary interface.
Precisely. Then there are substantial data access and security concerns. AI agents, almost by definition, operate by acquiring and processing massive volumes of data, as AWS puts it. This naturally raises significant data privacy implications, especially when an agent might be connected to multiple sensitive enterprise systems.
So how do we mitigate that?
Strict access control is paramount. The principle of least privilege is absolutely crucial here. Only grant the agent the absolute minimum level of access necessary to perform its specific job. Don't give it admin rights if it only needs to read a specific database table.
Makes sense. Limit the potential blast radius.
Exactly. Platforms like Amazon Q Business support fine-grained access control using things like AWS IAM Identity Center and IAM policies to ensure responses are based only on content the end user actually has permissions to access. And Azure OpenAI specifically warns developers, do not depend solely on excluding capabilities in the function definition as a security control. Meaning, just telling the AI not to do something isn't enough. You need technical enforcement of permissions, too.
And it sounds like companies are making very public commitments to protecting user data now, maybe going beyond the legal minimums.
They absolutely are, because trust is everything here. Airtable explicitly states its commitment to protecting customer data through ongoing security tech advancements, regular employee training, and rigorous compliance with regulations like GDPR and CCPAC-PRA. They offer secure encryption and give customers granular control over whether their content is shared for AI training.
So customers can opt out of training.
Yes. Notion AI makes similar promises, emphasizing no training on your data via contracts with their AI subprocessors using strong encryption, TLS 1.2+, offering advanced permissions, and holding key certifications like SOC 2 Type 2 and ISO 20001. They also have that zero data retention policy for LLM provider for most plans.
That seems critical for enterprise adoption.
It really is. Anthropic reinforces this with a clear policy. No training generative models on user-submitted data without explicit permission, and they state they haven't used any to date. Atlassian, with Rovo, centers its approach around privacy principles, focus on transparency, trust, accountability, and being human-centric. These proactive stances are becoming essential for building user confidence.
Okay, so prompt injection, data access, what other major risks?
Another critical one is hallucinated actions. We talked about AI making things up hallucinating. The risk gets magnified significantly when an autonomous agent acts on those fabrications.
Because the error isn't just informational, it leads to a real-world consequence.
Exactly. It could lead to incorrect orders being placed, wrong data being entered, inefficient processes being followed, or even dangerous outcomes in physical systems.
Yeah.
We saw the relatively benign example with Google's AI overview advising glue on pizza.
Right.
But imagine an agent hallucinating a command in a factory setting or making a flawed decision in a financial trade. The potential for harm is much higher.
So it's not just about guarding against malicious actors, but also against the AI simply being confidently wrong and then doing something based on that wrongness. That seems harder to predict or prevent.
It can be. Mitigation strategies include those human reviews we discussed, especially at L2 Autonomy. Careful prompt engineering also plays a role, giving the AI very clear instructions about its capabilities and limitations, telling it to ask for clarification if unsure, as Azure OpenAI suggests, guiding its behavior to stay within known, factual bounds.
And all these individual risks, prompt injection, data security, hallucinations, they all feed into the broader regulatory landscape, and ethical compliance is trying to catch up, right?
Absolutely. The EU AI Act is the most prominent example, setting a global precedent. As we discussed, it imposes those strict obligations on high-risk systems, risk assessment, data quality, logging, mandatory human oversight.
And it addresses the big models, too.
Yes, the general-purpose AI, GPAI models, requiring transparency and risk mitigation from their developers, especially for those deemed to pose systemic risks. Those rules are phasing in, with the full act applicable by August 2026, but key parts like AI literacy requirements are already active.
And outside the EU.
You have national frameworks like the NIST AI Risk Management Framework in the U.S., providing voluntary guidance on trustworthiness. And bodies like the UK's ICO are actively issuing guidance on AI's impact on data protection, employment, and monitoring. There's also a growing awareness of the ethical challenges. AWS explicitly notes that AI models may produce results that are biased or inaccurate, reinforcing the need for safeguards like human reviews. IBM talks about AI's iceberg problem, suggesting many risks are still unseen by organizations, and their latest data breach report strongly emphasizes navigating the AI rush without sidelining security.
It sounds like the consensus is building. You need a responsible, ethical foundation.
Yes, and Microsoft's Work Trend Index hints at this too, suggesting that unlocking AI's full potential requires addressing barriers beyond just technical capability, implying that ethical deployment and building trust are key to widespread adoption.
Okay, let's switch gears a bit. We've covered the capabilities, the controls, the risks. But ultimately, for businesses to adopt these agents widely, they need to see the value. How do we actually prove these AI agents are worth the investment?
Mm-hmm. The bottom line question.
Exactly. What does success look like and how do we measure it? What's that ROI math that leaders need to see before committing significant resources to deploying autonomous AI?
That is indeed the million-dollar question, or maybe the multi-million-dollar question for larger organizations. Measuring the return on investment, the ROI, for AI agents, it requires looking beyond just simple cost savings, although those are definitely significant and often the easiest place to start. It's really about quantifying efficiency gains, improvements in quality, and ultimately the broader strategic impact. You need to build a clear, compelling business case.
So where do you start? What are the key metrics?
One of those direct and usually easiest metrics to track is simply hours saved. This is often the headline number people look for initially.
How much time did we get back?
Exactly. Airtable, for instance, highlighted a customer who apparently saved more than 10,000 hours by consolidating various tools and leveraging Airtable's AI features. Now, that's not just a number on a spreadsheet. It directly translates into freeing up human talent. People aren't spending time on mundane, repetitive work anymore. They can focus on more strategic, creative, complex tasks that genuinely require human ingenuity and judgment.
So it's less about replacing jobs and more about upgrading them, allowing people to focus on higher value, maybe more engaging work. That's a powerful narrative.
Precisely. It shifts the human contribution up the value chain. Another key metric, especially for tasks where accuracy and the quality of the output are really paramount, is measuring quality deltas.
Quality deltas, what's that?
It measures the improvement or delta in the output quality or accuracy of tasks performed by AI agents compared to how they were done before, whether that was manual work or maybe less sophisticated automation.
Can you give an example?
Sure. We mentioned Amazon Q Developer achieving top scores on the SW Bench leaderboard for coding tasks like unit testing and code reviews. That's a quantifiable quality delta. It demonstrates the AI agent can perform at, or in some cases even exceed, human-level capability for specific measurable tasks, potentially leading to fewer bugs, better code maintainability, or higher overall software quality.
Okay, so hours saved, quality improvements. What else indicates success?
A really crucial metric, one that directly reflects the true level of autonomy and efficiency, is the intervention rate per 100 actions.
Intervention rate. How often a human has to step in.
Exactly. It tracks how often human intervention is required for a given number of actions the AI agent takes. A low intervention rate signifies higher agent reliability, greater efficiency, and less human overhead needed to manage it. If your agent makes 100 decisions and only needs you to correct it or approve something twice, that's incredibly efficient compared to needing intervention 50 times.
That makes intuitive sense. Fewer interventions mean it's working more autonomously.
Right. And closely related, especially for agents involved in service delivery or operational processes, is the SLA hit rate. SLA stands for Service Level Agreement.
Like meeting performance targets.
Yes. This measures how consistently the AI agent meets predefined performance targets. For example, response times for customer support inquiries handled by an AI, or completion rates for steps in an automated workflow. If an AI agent is handling IT support tickets, how often does it resolve them within the promised time frame? A higher SLA hit rate translates directly to better customer or employee satisfaction and improved operational reliability.
And I imagine cost efficiency is still a major driving factor, especially when justifying these investments.
Absolutely. AI agents can lead to significant cost reductions in several ways. We talked about retrieval augmented generation, or RA. AWS positions RA as a cost-effective implementation because it lets you extend large language models to specific company data or domains without the huge expense of retraining the entire foundational model. That saves a ton on compute and development costs.
Using existing models more smartly.
Exactly. Some agent frameworks are explicitly designed for efficiency. CoAI, for example, is highlighted as being optimized to minimize token usage and API calls. Since you often pay per token or per API call, this directly impacts the operational costs, making the AI cheaper to run day to day.
Lower running costs.
And even the choice of underlying model matters. Anthropic's Claude 3.5 Sonnet model is often lauded not just for its performance, but also for its cost-effective pricing, making it, as they say, ideal for complex tasks, such as context-sensitive customer support and orchestrating multi-step workflows without breaking the bank. These cost optimizations directly contribute to a better bottom line and a stronger ROI case.
Okay, so we have hours saved, quality, intervention rates, SLAs, cost savings. Is there a bigger picture view of ROI?
Definitely. Ultimately, the ROI of AI agents extends beyond these operational metrics to broader strategic business transformation. This isn't just about saving money or time on existing tasks. It's about enabling new capabilities and gaining a competitive advantage.
How so?
Well, remember, IBM suggesting the fundamental shift from systems of intelligence to systems of action. They argue that adopting agents is a strategic imperative for driving step changes in productivity and agility. Microsoft's Work Trend Index for 2025 goes even further, predicting it will be the year the frontier firm is born, where intelligence on tap will rewire business. They argue leaders need a new blueprint to unlock AI's full potential.
So the strategic argument is that not adopting agents could mean falling behind.
That's the implication. These larger narratives suggest that failing to adopt and effectively measure the ROI of AI agents isn't just missing a cost-saving opportunity, it could mean losing ground competitively. It's becoming less about optimization and more about future relevance and innovation. It's about staying ahead of the curve in an AI-driven world.
Okay, let's connect this to the bigger organizational picture. As these AI agents become more than just tools, as they become integral parts of our teams, actually making decisions, taking actions, who's actually responsible for managing them day to day? It's clearly not just about deploying the technology and then, walking away, right?
Yeah.
It sounds like we need an entirely new layer of team operations, maybe even a whole new discipline. What are people calling it?
Absolutely not a deploy and forget situation. You hit on a critical point for successful, sustainable implementation. Integrating AI agents means fundamentally rethinking traditional team operations. It means defining brand new roles, establishing crystal clear processes for oversight, for maintenance, for continuous improvement. And yes, this emerging field is often being called agent ops.
Agent ops, okay.
The question of who owns agent ops within an organization is paramount. And the answer usually isn't simple. It's rarely just an IT function or solely a development function. It almost always requires deep cross-functional collaboration involving IT, the business unit using the agent, data science, maybe even legal and compliance. Someone or some team needs to be explicitly responsible for the entire life cycle of these AI agents.
What does that life cycle involve?
Everything from initial deployment and configuration to ongoing monitoring of performance and cost to regular maintenance and updates, continuous optimization based on performance data, and maybe even eventually retiring an agent when it's superseded or no longer needed.
So it needs dedicated ownership. What's the first step in setting that up?
A really crucial step in establishing this new operational paradigm is creating clear OCI matrices. Responsible, accountable, consulted, and informed for both the humans and the bots involved in a workflow.
Applying ROS-CI to AI agents. That's interesting.
Yeah, it's taking a well-known project management tool and applying it to these new hybrid teams. It defines precise roles and responsibilities. Who is responsible for ensuring the agent completes a task? Who is ultimately accountable if it fails? Who needs to be consulted before changing the agent's scope? Who just needs to be informed of its activities? Defining this clearly prevents confusion, overlap, or critical gaps where everyone assumes someone else is watching the agent.
Like defining the agent's job description and its reporting lines within the team?
Exactly. Frameworks like CrewAI are even designed conceptually around this, helping you create an organization of AI agents with specialized roles collaborating to accomplish complex tasks, much like a company with different departments, each agent having its defined responsibilities and needing to coordinate with others, human or AI. It formalizes the hybrid team structure.
So it's about treating them almost like actual team members with defined
Mm.
roles. That's a significant mindset shift. What about managing their day-to-day operations, especially when things inevitably go wrong, as they sometimes do with any complex system?
For reliable, predictable operation, documented procedures, often called runbooks, are absolutely essential.
Run books for AI agents.
Yes. These runbooks should outline step-by-step instructions for managing and troubleshooting the agents. What do you do if an agent fails unexpectedly? How do you investigate unusual behavior flagged by monitoring? What's the escalation path for a security incident involving an agent? Those comprehensive audit logs we talked about earlier, like the ones Baby AGI generates, tracking function execution and errors, feed directly into the insights needed to develop effective runbooks.
So when an agent hiccups, the human team has a clear playbook to follow.
Precisely. It ensures a consistent, rapid response, minimizing downtime, mitigating risk, and operationalizing resilience. You're not scrambling in a crisis. You have a plan.
Makes sense. And just like human team members need performance reviews, do the agents.
In a manner of speaking, yes. AI agents require regular performance evaluations and reviews. This goes way beyond just tracking those ROI metrics like hours saved or intervention rate.
What else does it involve?
It involves deeply analyzing those audit logs, reviewing the specific instances where human intervention was required. Why did the agent fail or need help in that situation? Identifying patterns in its behavior, uncovering areas where its performance can be improved, its accuracy increased, or perhaps where its scope needs to be adjusted, either expanded or restricted, based on real-world results.
Learning from its mistakes, essentially.
Exactly. Remember the findings from that Elastica study? The flawed adaptations and failure to adapt instances? Those highlight the critical need for this continuous review and refinement cycle. You need to understand why the agent behaved unexpectedly and adjust its programming, its data, or its instructions accordingly. It's an ongoing cycle of improvement, not a one-time setup.
That implies a continuous process of learning and adaptation, not just for the AI itself getting smarter over time, but also for the humans working alongside it.
You've nailed it. This leads to a crucial dual focus on training and adaptation. Yes, it applies to the AI agents themselves. Continuous learning is a core principle. As AWS stated, they should ideally get better over time. But, just as critically, it applies to the human workforce.
Humans need training on how to work with the agents.
Absolutely. Teams need to be trained on how to effectively interact with these agents, how to monitor their performance using the tools provided, how to interpret the logs, how to leverage their capabilities effectively in their daily workflows, and when and how to intervene appropriately. Remember the EU AI Act's AI literacy obligations that started in Feb 2025. That directly underscores this growing importance of human understanding and competence in interacting with AI systems.
Yeah.
It's about empowering people to work with AI confidently and effectively, not just be passive recipients of its output or constantly fighting its mistakes.
So it's about building that collaborative muscle between humans and AI.
Exactly.
Yeah.
Ultimately, the most effective agent ops models, the ones that will likely deliver the best results, are those that foster a truly collaborative interplay between human skills, judgment, creativity, complex problem solving, empathy, and intelligent AI adaptation and autonomous action. As highlighted in the Elastica study, this dynamic interaction can lead to really high satisfaction of performance when agents react flexibly and reliably to human input while maintaining the desired quality and achieving the set objectives. It's about building genuinely symbiotic relationships between humans and bots to achieve goals more effectively and efficiently than either could alone. Hashtag #Atro.
Well, we have certainly taken a deep dive today into the truly fascinating world of AI agents. We've explored their capabilities, moving far beyond mere assistance into the realm of action and decision-making.
We've looked at the essential guardrails, the scopes, limits, sandboxes, logs, and that all-important kill switch needed for their safe and responsible deployment.
And we've examined the evolving dynamics of teamwork they introduce, the ROI metrics to watch, and this whole new field of agent ops.
The shift from AI assistants, the co-pilots we knew, to these decider agents, it really does represent a profound transformation in how work gets done. I think it's clear that AI is no longer just a tool for augmenting individual tasks.
No, it's becoming an active participant, sometimes even a leader, in complex, multi-step workflows across practically every industry. This isn't some distant future scenario. It's actively happening right now.
Absolutely.
So as we wrap up, here's a thought to leave you with. As we move towards a future where AI agents routinely take autonomous action, maybe even collaborate with each other, what new forms of collaboration will truly emerge between humans and these increasingly capable machines?
That's the big question.
Will human roles increasingly shift towards becoming orchestrators of vast AI workforces, defining the high-level objectives, setting the strategy, overseeing the outcomes, maybe a bit like a conductor leading an orchestra of specialized bots?
Or will the AI agents themselves become sophisticated enough to manage other agents to an even greater degree, forming complex, self-organizing digital teams that require even less direct human management for routine operations?
It really makes you consider the long-term implications for organizational structures, for skill requirements, and maybe for the very nature of human work itself, as these autonomous entities become more and more prevalent in our workplaces. Something to definitely keep thinking about.
Lot to mull over.
Thank you so much for joining us on this deep